Today, we will be discussing about simplification of function using Quine-McCluskey method. First is, we convert these implicants into its binary form using the code 8, 4, 2, 1. Recall that 1 is derived from 2 to the 0, 2 is 2 to the 1, 4 is 2 squared, and 8 is 2 cubed. To get the binary equivalent to 4, we simply think which of these numbers are to be added to have a sum of 4. So definitely, we have only 4. So this will be 0, 1, 0, 0. And that is the binary equivalent of 4. Let's try 12. So, what are the numbers are we going to add to have 12? So, that would be 8 and 4. So, 8 plus 4 is 12. So, the rest would be 0. So, that's how we convert numbers, these prime implicants, into its equivalent in binary form. The shortcut method. So, the next, so 0, no ones for 0. For 4, we have 1 ones. For 8, we have 1 ones. For 12, we have 2 ones. 14, we have 8 plus 4, 12 plus 2 is 14. So we have 3. For 15, we have 4. So when we add 8 plus 4 plus 2 plus 1, the total is 15. So we are now ready to get the part 1 for the Quine-McCluskey method. Part 1 is we simply determine the prime implicants. Okay? So we determine the prime implicants. So for column A, we simply group these implicants according to the number of ones they contain. So we have 0 as the first group, since no other numbers which do not have a 1. So we put a dividing line. The next would be all implicants with 1 ones. So that would be 4 and 8. Write a dividing line. Then with 2's, you have 12. Then 14. With 3 ones, and then the last, of course, dividing line again, the last would be 15. So let's check. 1, 2, 3, 4, 5, 6. So 1, 2, 3, 4, 5, 6. So we have 6 implicants. The next, we go now to column B. To get column B, we have to compare the two adjacent groups. So meaning, we compare the first group with the second, second with the third, third with the fourth, and fourth with the fifth. So, we now compare 0 and 4. 0 minus 4 is 4. Note that the difference should be 1, 2, 4, 8, or any powers of 2. So, 0 minus 4, since that's 4, we write now 0 in column B, separated by a comma, the 4. Since we covered the 0 and 4, we put a tick mark or a check mark, and then the difference should be placed inside a parenthesis. So we're going to have it as 4. Now, if we're going to associate it with in binary format, we have here 0 and 4. 0 is 0, 0, 0, 0. 4 is 0, 1, 0, 0. You will notice the two numbers only differs at this position. So therefore, I could rewrite it as 0 dash 0, 0. You will notice the two numbers or the two implicants only differ in the third position, or simply that is the 4. So that is why you have 4 in here. So remember, this is the 1, 2, 4, 8. So that is why you have here 4. Then next, we proceed. We then compare 0 with 8. Okay? So you compare 0 to 8. So since the difference is 8, we put a tick mark sa 8 and then we put 0, 8, a difference of 8. Since we're done comparing the two groups, we now put a dividing line. Then next, we go to the second and third group. Same procedure. We compare 4 by 12 and 8 by 12. So 4 minus 12 is 8. So since that's 8, a power of 2, so we put a tick mark. So that would be 4 and 12, a difference of 8. The next, 8 and 12, a difference of 4. So 8 minus 12 is 4. So since it has already a tick mark, I'll just write it in column B, 8 and 12 with a difference of 4. Since we're done, we put a dividing line again. So we compare this time 12 and 14. 12 minus 14 is 2. So that will be 12, 14, a difference of 2. So put a tick mark. So since we're done, we put a dividing line again. And then, we compare this time 14 and 15. So 14 minus 15 is 1. So you put the tick mark, 14, 15, a difference of 1. Okay? So, if we're going to this one in column B, we simply group the implicants by groups of 2. Okay? So, for column A, you simply group it by 1. So, if we're going to associate it with K-map, it will look like this one. So, if we're going to compare, you will notice we have here 0, 4. That is 0, 4 here. Then 0, 8. That's one here. Okay? So, we have here, if we're going to compare it with the K-map, this is sideways by the way, since A is written in here. Again, you have 0, 4, this group, that one. Then you have 0, 8, this two here. You have here 0, 8. Then we have 4, 12, this one. Okay. Then we have 8, 12. The green, this green here. And then the 12, 14, this one here. And then 14, 15, that one here. So, you will notice, if we're going to relate Quine-McCluskey method or the tabular method with the K-map, we simply group the ones by 2s here. And for A, it's by 1s. Okay? So, the next, we proceed with column C. To get column C, this time, we do not compare all implicants. We simply compare those set of implicants with same difference. Meaning to say, we will only compare these 4 here and 4 here, 8 and 8. Okay? So, the next, same procedure, we get the difference of 0, 8. 0 minus 8 is 8. Now, you can also compare 4 minus 12, that is also 8. Now, since the difference is 8, which is in powers of 2, we therefore put a tick mark. Okay? So, again, we write the number 0, 4, 8, 12 in ascending order. So, 0, 4, 8, 12, a difference of 8 this time. But the previous difference is 4, so I'm going to write it in ascending order, so 4 and 8. Now, take note, when you write the numbers in column C, I suggest that you write the numbers in ascending order for you to be able to determine which sets are the same. Then next we proceed 8 by 8. So we compare these two sets. 0 minus 4 is 4. So 4 is in powers of 2. So therefore, we can actually use this one. So this will be 0, 4 again. You write it in ascending order, 0, 4. And then you have here 8 and 12. A difference of 8. But the new difference is 4. Okay? Since we're done, we put a dividing line. So we proceed with this one. But you would notice the differences here are 8 and 4, whereas in here we have 8. So nothing to compare. So we proceed with the next. This one is 2 and then 1. Again, no similarity. So then we stop with at column C. Now, you will notice that in column C, the sets should be in pair. So you would notice this one are the same. So this will just be treated as 1. Next, we go back. Those numbers with no tick mark or check mark, that will now be our prime implicant. So we place or we put an asterisk. Okay? So I label this as X, Y, and Z. Okay? Then, we're now ready to get the essential prime implicants. To determine the essential prime implicants, we have here 3 prime implicants. Okay? So the implicants are 0, 4, 8, 12, 14, 15. What we're going to do is, we're going to draw a matrix. Okay? So we're going to draw a matrix. On the first row, we write the prime implicants which are 0, 4, 8, 12, 14, and 15. So that will be the first row. On the second row, we're going to place the prime implicants which are your X, Y, and Z. So I'm going to place here X, Y, and Z. Then, take note, your X is 12 and 14. Okay, so let me write in here. So you have here 12. This is 14. For Y, we have 14, 15. Then for Z, you have 0, 4, 8, 12. 0, 4, 8, 12. Then, so we're going to map this. For X, we simply put a cross under column 12 and 14. Then for Y, we have 14 and 15. For Z, you have 0, 4, 8, and 12. Then next, after plotting all these implicants on this matrix, we now determine the essential prime implicants. But before that, we have to check which among these implicants belong to a group. So, we put a check mark at the bottom first, but then how? First, we go to column 0. So at column 0, we have only one X, so therefore we put a check mark. Since we we put a check mark on 0, and that is covered by letter Z, which at the same time also covers 4, 8, and 12. So therefore, we're going to put a check mark. Okay? So I repeat, 0 has only one x, so I put a check mark. But since this x belongs to this group, so therefore, I will also put a tick mark or check mark under this x's. The next is column 14. You will notice in 14 we have two x's. So for now, we cannot put a tick mark because the ruling is it should be only one x along the column. Then I'll proceed with 15. 15, I have one x, so I'm going to put a check mark. Since I put a check mark on column 15, this x here also this is also belonging to group Y, to which 14 also belongs to group Y. So therefore, I'm going also to put a tick mark. Okay? So, for now, you will notice all the columns have a tick mark under its implicants. But later, I'm going to show you other examples to which one or two or more of these columns do not have any tick mark. Okay? Then next, we now determine the essential prime implicants. So there are two requirements to determine what are the prime or essential prime implicants. One is all x's, all these x should have a tick mark at the bottom. Second, one of these x's should only be only the x covering such implicants. So let's assess x. X, we have two x's here. It covers 12 and 14. And notice that 12 has a tick mark, 14 also has a tick mark. Okay? But then your x here has another x here. So 14 has two x's, which is covered by prime implicants x and y. So therefore, this one for now cannot be considered as essential because though these two x's has a tick mark on it, but then this x here has another x here, so with this one. If we're going to relate it in Karnaugh Map, we have here the 12 and then 14. Okay? We have here 12 and then the 14. You will notice this is a redundant group because this one is already belonging to group orange. Okay? And this one here also belongs to group yellow-green. Or it actually is grouped with 8. This one is grouped with 14 is grouped with 15. So in other words, this 12 and 14, if I'm going to group it again in K-map, that is a redundant group. Okay? The next for Y check. Y covers 14 and 15. And X here has a check mark here. 15 also has a check mark here. Okay, so it actually met the first requirement. Second requirement, one of these x's should be the only x covering such implicants. So in here, x here has another x, but then x here, it's only the x covering 15. So therefore, this is now an essential prime implicant. So I'm going to put an asterisk indicating that this particular set is an essential prime implicant. Then we proceed with prime implicant Z. Z covers 0, 4, 8, and 12. X has a tick mark. This one, same thing. Also with this one. So it actually met the first requirement. Second requirement is one of these four x's should be the only x along the column. So you will notice this is only the x for 0, for 4, and 8. So definitely, this is an essential prime implicants. Then next, we now check if all these prime implicants are already covered by these essential prime implicants. So for y, it covers 14 and 15. Y, it covers 14. So I'm going to encircle it, and then 15. Okay? Z covers 0. Okay? So I'm going to use Z here covers 0, 4, 8, and 12. So therefore, all the implicants are already covered. So therefore, we can say that y and z, y plus z, already covered all the implicants. Y covers 14 and 15. So you just select one. It's either 14 or 15. Say I'll choose 15. For z, it covers 0, 4, 8, and 12. So I choose 0. Then next, I'll be converting these numbers again into its binary form. Again, using the code 8421, 8421. So, to convert, what will be the numbers to be added to get a sum of 15? Definitely that will be 1, 1, 1, 1. So 8 plus 4, 12, plus 2 is 14, plus 1 is 15. Plus, of course, for 0, that will be all zeros. Again, we go back to part 1. For part 1, your y has a difference of 1. For z, a difference of 4 and 8. So, what we're going to do, for y, we have a difference of 1. So, meaning, I'm going to cancel out the 1 in here. And then for z, we have 4, 8, 1, 2, 4, and 8. Okay? So, if I'm going to associate it, this one is the difference. Okay? The hyphen. Then, we now get the equivalent mean term. Now, note that this is A, B, C, and D. A, B, C, D. Now, A is 1, so therefore that's A. B is 1, therefore that's B. C is 1, so therefore that is C. Since 1 here is cancelled out, so the equivalent mean term will only be A, B, and C. Plus, A here is cancelled out, B is also cancelled out. C has a 0, so therefore that is not Z. D is 0, therefore this is not D. So, the equivalent sum of product of that particular function is equal to A, B, and C plus not C and not D. So, this function will now be reduced into this form. Let's try to look at the solution using Karnaugh map. So, again, you have A, B, C, D. The mean terms are 0, 4, 8, 12, 14, and 15. Earlier, we've shown this one. We grouped the ones by twos. Now, this time, we get the biggest group. That is by 4. So, instead of grouping the 0, 4, 8, and 12 by 2s, we now group it by 4. So, we have only one group of 4 and then another one group of 2. So, therefore, if we get the mean term for this group, this would be C, D. We have here this group covers 0, 0, 0, 1, 1, 1, and 1, 0. Again, For this is column A, this is column B, C, and D. So, for 0, 1 here, so 0, 1 cancel, 0, 1 cancel, 0, 1 cancel, 0, 1 cancel, 1, 0 cancel. So that's simply 1. Then for column CD, 0, 0, therefore this is not C, not D. Not C, not D. Okay, so times 1, that is still not C and not D. Plus, the orange group here, that only covers 1, 1, so therefore this is A and B. Then for column C, CD, it occupies 2 columns, 1, 1 and 1, 0. So 1, 1 here, that's 1, what says C, so therefore that's C. 1, 0 here is, 1, 0 here is cancel, that is for D. So the answer is only C. So the final answer would be, the SOP equivalent would be not C and not D plus ABC, to which if you're going to compare here, using the Quine-McCluskey method, we actually obtained same result. Now recall again that column A, you group it by 1. Okay, so 0, 4, 8, 12, 14, and 15. That is for column A. For column B, this is by 2s, as discussed earlier. And for column C, that is by 4. Okay, so that is by 4. We have 0, 4, 8, and 12, which is at column C.